Now the next application we're going to consider is a distance rate time problem. And the problem is this. We're told that a train travels 600 miles in the same time that a truck travels 520 miles. And we're asked to find the average speed of each vehicle if the train's average speed is 8 miles per hour faster than the truck speed. So if we organize the information into what we know and what we don't know, we can see first that we're told that the distance the train travels is 600 miles. The distance that the truck travels is 520 miles. They both travel the same length of time. We're told that the train speed is 8 miles per hour faster than the truck speed. And the underlying formula we're going to need to use for this, which you've seen before, is that distance is equal to rate times time. And what we don't know that we need to find out are the speed of the truck and the speed of the train. Now what we need to do next is to represent each of the items in the unknown column using a variable. So I'm going to choose to let capital N represent the speed of the train and capital K to represent the speed of the truck. And you might wonder how I came up with those variables. It's just that I happen to use the last letter of each of those words. Now before we write the system of equations that we need to solve this problem, I think it'll be helpful if we organize the information into a chart. So I've made two rows here. The first row is labeled the train, the second row labeled the truck. And I've listed the distance formula across the top there where you can see its distance is equal to rate times time. So I've put 600 in the distance column for the train and 520 in the distance column for the truck. The rate for the train, capital N, the rate for the truck, capital K. Now one variation of the distance formula is that time is equal to distance divided by rate. So in the time column then what we can write for the train will be then 600 divided by N, and the time for the truck we can then write would be 520 divided by K. So now we're set to write the system of equations we need to solve the problem. Now we're told that the time for both the train and the truck are the same. So that would mean we could then write next 600 divided by N is equal to 520 divided by K. And we're also told that the train speed is 8 miles per hour faster than the truck speed. So then we could write as our second equation N being equal to K plus 8. So this is the system of equations we need to solve the problem. Now this is a system that lends itself very naturally to the use of substitution. So what we can do is to take the value for N that we see here and then substitute it for N in the first equation. So then we'll have next 600 over K plus 8 is equal to 520 then divided by K. So what we'll do next is to cross multiply and solve this equation. So continuing with the equation that we created in the last step, which was the 600 divided by K plus 8 equals 520 divided by K. If we cross multiply, I think you can see that what we'll get then 600K is equal to 520 times the quantity K plus 8. If we distribute it on the right hand side, we'll get 520K plus 4,160. And then subtracting 520K from each side, we end up with 80K is equal to 4,160. And then dividing each side by 80, we end up with K then being equal to 52. And the other equation in our system, you remember, was N is equal to K plus 8. So that would tell us then that N is equal to 52 plus 8 then, or 60. So if we write a sentence answering the question, we can say then that the truck speed is 52 miles per hour and the train speed is 60 miles per hour. Now if we check those values back in the equation we created at the top, we'll have then 600 all over 52 plus 8, and we hope that will be equal to 520 divided by 52. So we then have down below here 600 divided by 60 and 520 divided by 52, and they both simplify to 10. So those values do check in that equation.